Hi everybody. In this video we are going to evaluate this expression below given the same information as in example 1 of this set. Sine of angle U is 3/5 with angle U existing somewhere between pi over 2 and pi, quadrant 2, and cosine of angle V is equal to -5/6 with the condition that angle V exists somewhere between pi and 3 pi over 2. So one other thing I'll throw in this explanation is if sine is a positive ratio, that means it exists either in quadrant 1 or quadrant 2, and then this information narrows it down for us. Similarly, cosine of angle V is negative in quadrants 2 and 3, and this information narrows it down for us. We are going to find tangent of U plus V, and similar to an earlier example I did, which will be shared below in the description box, you can opt to find tangent of U plus or minus V using sine over cosine of U plus or minus V, or using the identity specifically for tangent. In the earlier example, it turned out to work out a little bit nicer when we use the tangent identity, so let's see if that's true this time. So let's start off by doing sine U plus V over cosine U plus V. So I'm just going to write out what we are doing first. We are using this approach, and we should know each of these identities by heart. Sine U, cosine V, sine keeps the same sign, cosine U, sine V, over cosine, so we get two cosines together, we get two sines together, cos, C opposite S, U, V, U, V. Now, for the full explanation for this example, you have to go back and watch the previous example, because I'm not going to take the time to explain the same thing twice. So I have written this out on a separate piece of paper. So if you did not watch that, then I strongly suggest that you find the video for part 1 of this. It was an example where we evaluated cosine of U plus V, and I fully went into detail as we put this together. So we're just going to reference this at this point. So in the next example, this right here still represents tan of U plus V, so I'm not going to write sine over cosine every time. Fraction, fraction, plus fraction, fraction. It could be over 1, but there'll always be a fraction over 1 if that's the case, because it's sine and cosine and the hypotenuse has to be the biggest side. Yada, yada, yada. Oops, I just wrote a plus sign. That's not correct. I don't know where my whiteout is. Okay, sorry about that. Now it's really just filling in, right? Sine of U, it's going to go right there and right there, so let's just do it all at once. So there's 3/5, 3/5. Cosine of U is -4/5. That's also going to go in 2 places, -4/5 and -4/5. Sine of V is negative radical 11/6. And cosine of V was given in the original problem. It was -5/6. All right, so we have got this going. We got this started. Next step, I'm just going to kind of wrap it around right here. -15/30. Again, don't reduce. I know you might want to. It's going to make your life harder. This will be over 30. Over 30 over 30. So before we do anything, I'm going to multiply the whole top and the whole bottom, and I went into a lot of detail explaining this in an earlier example. Again, that'll be linked below. But I'm going to multiply the whole numerator and denominator by 30. If you don't want to think of it as 30, or maybe the numbers are bigger, like 51 and 37, then write 51 and 37, and then reduce what you need to reduce, okay? 5 and 6 are being multiplied here. Then the 5 reduces, the 6 reduces. Same here, 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 and then as long as I do it on bottom, everywhere, it's gone. Could you write 30? Yes, but if the numbers were 51 and 61 and you don't actually want to multiply them, you write 51 and 61 and just cross them out as you go. So what's going to happen? All the 5s and 6s from these denominators will reduce with this 5 times 6 combo out here, and we're going to be left with negative 15 plus 4 root 11 over 20 minus negative plus 3 root 11. Guess what we still have to do? Same thing we did before. Rationalize our denominator. We do that by multiplying both the numerator and denominator by the conjugate of the denominator, which is 20 minus 3 root 11. 20 minus 3 root 11. When you turn in work, I know that sometimes you know what you're doing and you organize things in your head, but show those parentheses when you turn something in, the fraction bar, whatever details that you think might be important, okay? Include them, especially the parentheses, especially. Now, on our denominator here, we're going to use FOIL. I would refrain from using a calculator as much as possible. You really don't need it. I think you can handle this, so we'll see how this all goes. So let's go from there. Here we are going to have 20 times 15. Well, 15 times 2 is 30 and another 0, so we're going to have negative 300. Outer plus 45 root 11. Inner plus 80 root 11. And then last times last, 4 times 3 is 12. It'll be negative 12. And then negative 12 times 11. You should know 12 times 12 is 144. Take away one of those 12s from 144. 134, 2 more, 132. So it'll be minus 132. Also, 11, root 11 times root 11 is 11. Times 3 is 33. And then whenever I multiply by 4, I just double twice. So 33 becomes 66, and then 66 doubled is 132, okay? Whatever way, you just get the right answer. From there, first times first, 20 times 20, 400. Outer and inner, we don't need to worry about. They're going to clear out. Last times last is minus, 3 times 3 is 9. Root 11 times root 11 is 11, so that's 99 right there. Next, we're going to clean up a smidge more, and we will get negative 432 plus 125 root 11 all over 301. That is the tan of u plus v. If you want to see, now this one, I have to say, I think doing it this way, using sine and cosine, is actually harder. And then had we done it, do I think this one's harder? I think. And if we do it using sine and cosine, I think it's a little bit cleaner, but you're going to have to check it out and see for yourself. And that'll be in the click through at the end. And it'll also be, sorry, my alarm. It'll also be linked in the description box below. So to see this solved using the tangent angle sum identity, just look for that popping up on the screen probably now. If you did it this way and you got the right answer, you could put thumbs up. If you did it a different way and got the same answer, you can give it a thumbs up. Otherwise, put thumbs down, because if you didn't get this answer, you got it wrong, right? Better luck next time. But check out the video, okay? Practice makes improvement. See you in the next example.